Hey everyone, welcome back to yet another episode of GenAI Vlog. So this couple of episodes, we're talking about Gradio application. It's an open source Python package that allows you to quickly build a demo, a web application to demonstrate the capabilities of your ML models, your APIs, your large language models, or whatever model that you fine-tuned, or it could be even just arbitrary Python functions, things like that. It will allow you to share a link of your demo with people in just a few seconds with lots of cool features. So I want to get people started because I receive lots of questions from my students, how to demo, right? How to run your demo, how to run a cool interactive presentation. So this couple of episodes, we're going to get things started. Today, we're going to focus on vision question answer, right? Also known as VQA. So it's a multimodal framework and it's going to consume both image and a sentence, which is a string, also known as text, as input, and it's going to produce some sort of response back, right? So it's image text to text model. So this is a notebook. First things first, we're going to pip install Gradio and transformers. And then what we're going to do is we're going to load in a blip model. Blip model is produced by Salesforce. It's a VQA-based model, and that's the model that we're going to download. And it has its specific processor and model. So just like large language model with a tokenizer and a model, the VQA, vision question answer, also has some sort of tokenizer, right? Except that it does not call tokenizer because it also process images. So it's called a processor, and then the processor will help you do some processing with the model, tokenize it, concatenate the tokens, concatenate the input, things like that, and then it will send that into the model, right? So that's what's happening here in this particular function. So this is where the inference happens, right? This is the VQA answer inference function. It takes an image and a question into the function as input arguments and then it will process it with the processor, send that to the model that generate whatever the output that we got. We're going to decode it so it becomes a actual sentence. And then we're going to return that sentence as a final answer. So that is the inference function. Now we just need to design the user interface, right? So it's very simple. We're going to define Gradio interface and we only need three things, right? We need a function, input, and output. Function, we just talked about it. It's the VQA answer that's defined up here on line 9. The input, we talk about, there are two, right? There are two inputs. One is radio image. So this physically lets the user to upload the picture. And then there's also text box, right? Text box basically means user can then send in a question. You can type something down physically using natural language. And then whatever the output that you get, it's going to be another text box, and we're going to print something in there. And then last but not least, we have title and description. These two things is just purely for aesthetics, right? For readability, and that is really it. Also, previously, we have been running this in one line, right? Gradio interface dot launch. In this particular case, we're going to make things a little bit easier for us. We're going to define all of this interface as a demo, and then we're going to launch a demo that way. Because this is, as you can see here, getting very long. So we're going to do demo.launch in the very end, and we're going to trigger the app that way. So once you run that, you can then interact with this application within your notebook, or you can click on this public URL, and then you can then upload a picture. So I'm going to physically upload a picture of a screenshot of a bird, and then let's see what's going on. So this is a screenshot of a bird, and then we're going to take a few seconds to render it, and then we're going to enter a question. So we're going to say, what animal do you see? Something like that, right? Something simple. We're going to hit enter. It's going to physically run inference using the model, using the infrastructure in this Colab, right? So that's why if you go to runtime, I actually have a GPU selected because I want to be a little bit more faster, right? If you were using a default runtime type, it's going to use CPU as hardware accelerator, and then obviously that's going to be a little slow. So you give it a minute, and then it's going to say, oh yeah, it's in the upper part of the body or something. And it may not give you the correct answer, but that's okay. It got something back, right? It got something back. Now, what's going to happen is you can actually load in your own model, right? Just like what I'm doing here. So Eagle 0504 Blip VQA, that's actually a model from my own Hugging Face. So if I may, I can then select this, and then I can show you what that link is, right? But this is the link. I fine-tuned this model myself, and I push it on Hugging Face. I didn't do anything crazy. I just went through the process of fine-tuning it with a couple of sample pictures, and then it may or may not work, right? But anyhow, the weights are here, right? The weights are here, models here, processor here, tokenizers here. You get the idea. And then what that means is if everything's here, then I can run this app and I can launch it, right? It will download the model, right? Tokenizer processor, download the model, vocabulary, tensors, right? Things like that. And then it will allow you to drop a picture. So what I'm going to do is open up as the web app, and I'm going to drop the same picture, and then just show you guys what the output look like. So that's the picture, and then I'm going to physically submit it. And then in this case, you probably get the idea, right? There's what is present, a hand, something like that. This is obviously not a hand, just because the model is not very well fine-tuned. But you get the idea. You're going to get some answer back, and then obviously I'm going to pose this as a question for my students probably. And then hopefully if you can fine tune this, get the accuracy up, then maybe we can read this picture a little bit more accurately. So with all that being said, that is a VQA setup. Even though the model is not accurate, right? The model is not accurate, but that's okay. The setup is here. We can always fine tune this model, and we can then always load in your own model. So the interface is essentially here, and that designs the UI, and that's hooked up with the inference. So there you go. Thank you for watching. Subscribe and like.